Hello, today we're going to use the EasyVR3 Shield on a Mega to control a ULN2003 stepper motor. We're going to connect the stepper motor using a 28BYJ48 board. Now this board you order, when you order the stepper motor, it comes as a set. You plug it straight in, and then the pinouts come into pins 8 through 11. And then the power and the ground. I do have an LED that is being activated that indicates that it's okay to go ahead and say a command. So while it's on, it's waiting for a command. So while we're doing this, let's go ahead and reset the board, and you'll see over here on the screen the output. So we reset it, and it comes up, and it actually says, bridge not started. I wrote them, the EasyVR3 folks, and they said that that's not significant since I'm using the Shield. So what's also interesting here is the code will recognize a trigger, which is one of the command sets, and then there's the group, which is speaker dependent, or SD. Those are ones that I programmed in, which is the direction of the motor, either clockwise or counterclockwise. Oh, and see it. In this case, it thought I said motor. Now it's asking for a direction. Let's say clockwise. And now it's asking for a word set, and it thought I said 4. So now this is going to spin 4 times. So what's interesting about this is we're using a trigger, a group that is speaker dependent, and a word set that is speaker independent, meaning the 4, anybody can say it, comes preloaded on the board. So there's motor, counterclockwise, 1. So now it's going to rotate 1. So let's try it one more time. Motor, clockwise, 5. And so now it's going to rotate 5. And these red LEDs are actually flickering, but they're flickering very quickly. They show the different states of the motor. So I have that in the code, and when we break out to the code, I'll show you how you get to go clockwise or counterclockwise. Next time I'll do it counterclockwise. So it's still spinning. Motor, counterclockwise, 2. And for the most part, the voice recognition is pretty good. And you can see the LEDs off because it's actually performing the function. The speaker independent work set is pretty lenient. You can almost say anything and it will work. I'm not sure my trigger is working exactly right, because sometimes it picks up noise and it thinks it's the actual trigger of motor. Motor, clockwise, 7. So now it's going to do it 7 times. So that's kind of how it works. It's pretty straightforward. This is a smaller video, so I wanted to just show how to use voice control to control a stepper motor using this little kit right here. I will show more of it on a screen close-up when we cut to the code. So let's go ahead and do that now. Here we have an overhead shot of the EasyVR3 Shield on a Mega. You can use an Uno. Either one is fine. The green light shows that it's ready to accept a command, and now the stepper motor is spinning according to the commands received. Here we have the fritzing diagram showing the wiring for the stepper motor to the motor board connected to pins 8 through 11 on the Uno. So I want to explain the hardware that I used for this project. It's a real simple little project. It involves, of course, the EasyVR3 shield for the Arduino. You can buy it at Amazon, other places on the web. It ranges about 30 to 50 bucks. The shield includes this board here and the EasyVR3 module here. And what you wind up doing is you take these little pins down here and you solder them onto here, and then you solder the whole thing onto this shield, and then these are pass-through shield headers that go on the periphery of the of this EasyVR3 shield, and then they plug into the Arduino. The Arduino Mega or Uno, so that you can still use the pins underneath. This is a microphone, and this is a cable for the 8-ohm speaker, which is sold separately. They plug in right here. So that's the shield. And I have other videos if you want to find out more about that. I suggest watching some of my other videos. This is the 28YBJ-48DC 5-volt 4-phase 5-wire stepper motor with the ULN 2003 driver board. And here's the board here. I think I can zoom in a little bit larger. You see here's the motor itself. Another picture. It has a little metal tab that you can anchor using a set screw if you want to mount something to it. Here's the back of it, and here's the connection wire that actually connects to this board right here. The motor is not terribly strong. It doesn't have a lot of torque. It is very consistent. It does have fine resolution. I think it's 5 degrees or a little bit more than 5 degrees. So it can do a lot of positions, and I've had it running all day long when I was prototyping a sketch, and it's quiet, and for $2.80 you can't beat that, and I'm very pleased with it. I'm not sure it really could drive wheels or a robot or a bot car of some sort, but if you had a couple of them, maybe if you had 4 of them, you probably could do fairly well. So not the strongest motor. Because the magnets in here are kind of small, you can kind of hold it. Most stepper motors are much larger, and the magnets are so powerful that you really can't stop it or twist it. This one you can, so keep that in mind if you're looking for a more powerful motor. This may not be your first choice, but you may want to get this just to write the sketch and kind of get the feel of stepper motors. This little board here is kind of nice. It has some LEDs. Right here, 4 LEDs to tell you the phase or the step that it's in, and I'll show you the breakout chart for the stepper motor here in just a second. So I bought this and thought I would try it. They suggest if you're going to use a couple of these stepper motors not to drive them directly from the Arduino Uno or Mega, because the power, the pull of the current, you could damage your Arduino. I had just one motor running, and it seemed to be okay, but you may want to get a motor driver board or a separate power supply. I'm not sure. I think this has the power supply is here. There's a jumper here that does something else, but I'm not really sure what it does, to be honest. And there's another header block here that I have not used. So those can all be programmed to do other things. What is nice about this chip is sometimes this ULN 2003 chip is actually surface mounted to the board, and if you blow that chip, then you got to get a whole new board. This one you can actually remove the IC chip and put another one in. So I guess there's 2 different versions, and I'm not sure how you specify one or the other. It's just whatever you get. So this is the stepper sequence, and I wanted to kind of tell you a little bit about this. This was kind of the heart of how to make the stepper motor go forward clockwise or go counterclockwise. And the way it works is here, obviously you can see all the different colors, and it breaks it out by wire number, but it's really the colors that are important. And then each step, there's 8 steps. And basically, whenever there's a tick mark right there, you set the wire number 4 or the orange wire to high. These are all low. So step 1 would be you would have 1, 2, 3, 4, and then you would have low, 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 high. And then for step 2, you'd have low, oops, let's go back. Low, low, high, high. And then step 3 would be low, low, high, low. And then 4, low, high, high, low, and so on and so forth. And you would call out each step, and then you would call each step 1 through 8 to go clockwise. If you want to go counterclockwise, you would start off with 8 and go down to 1. And I'll show you that in the code. And that's really how you go forward or backwards using the stepper motor, the ULN 2003 stepper motor. So lastly, I wanted to show you, here are some websites that I found very helpful and explained how the stepper motor works, how to wire it up. This one up here at the top wires it up a little bit different, but fundamentally it's still the same. The wiki page gives all the information you'll need to know, and then here's the stepper sequence down here at the bottom. I did contact the folks that make the stepper motor, and they sent me the tech sheet on it, and it's a one-page tech sheet that you can find anywhere. On a Google search, it shows the picture of the motor, similar to Amazon. So you can try writing them and getting the information, but it really doesn't give you any more than what you can already find. So I wouldn't wait for it. So here's the sketch, and I wanted to start out and say this sketch can be viewed running on YouTube by searching for Scott Mon, that's capital S-C-O-T-T, space capital M-O-N, and clicking on the corresponding video clip. I have several other clips. I have quite a few clips on the EasyVR3 Shield. I have a motor drive shield also, but that's a little bit different, not a stepper motor. Anyway, just want to put that out there. So, getting into this, let's start off here. I broke down the libraries. This is the library to not do, but to drive the EasyVR3 Shield. This code is generated automatically by the EasyVR Commander program, generated code option, and it's all necessary in order to establish a bridging for the EasyVR3 Shield to communicate to the Arduino. I actually had some problems. I don't know if there's something wrong with my board or the software or something. The bridge could not be established. I wrote the EasyVR3 company, and they said that don't worry about it. It's just for comment, so it'll still work, and it does. It works great. The VR3 works great. So I don't know. I was getting an LDEXE error for a while, and I got rid of that somehow. So anyway, just so you know, sometimes this thing, gets a little glitchy or whatever, and a little temperamental, and you got to just do the best you can. I do want to mention that this sketch is unique in the fact that I'm using a trigger word. I'm using a speaker dependent or SD command, one that I've trained the EasyVR3 Shield to recognize, which are the words clockwise and counterclockwise. And then lastly, I'm using a word set, which is built into the EasyVR3, which is what's called the number set, or the last, or word set number 3, which ranges from 0, 1, 2, 3, all the way up to 9 or 10, and they're built in, and anybody can say those numbers. So those are speaker independent, or SI. So with that out of the way, let's look at some of the code. This is all comes pre-done for you. I added this. I've been adding this now to a lot of code so that it stops opening the same .h files, and so far it doesn't seem to cause any issues, and I think my compile actually is a little bit cleaner. Lastly, this EasyVR port is all part of this handshaking up here. And I think primarily this handshaking is used just if you use the module, not the shield. So I think that's why it's not really that important. Here it is right here. It says software serial. Well, I'm not doing software serial. I'm using the shield, which I think is hardware. You do have to use a very current version of the IDE. I'm using 1.6.5. Normally I use the Windows Enhanced release, which is 1.0.5, and that would not work with the EasyVR3 Shield, so you have to use a more current version. So here are the variables I set up for the sketch. Here's the set, here's the group, an index. This is all for accessing the commands. Number of revs, obviously the revolutions. When I give it a command, I need to store the actual integer, numeric integer, so that I can do a for loop to count down the number of revs. The green LED pin, I just put that on there just to do it. And then the rev direction, I save that. Depending if it's a 0 is clockwise, a 1 is counterclockwise. You can see that right here. And then store the command name. I kind of like to show that on the screen so that it's just kind of nice to see the name, you know, motor, clockwise, 10, whatever it is. So here's groups and commands, and I have two groups. The first group is motor, and I've recorded that using the EasyVR3 commander program and stored that on the board. Here's group number 0 and then number 1. Here are the directions in this case. Clockwise is 0, counterclockwise is 1, which is what it says up here. Okay, so now we come up to the setup. That's all I had to do. It's real simple. Decide which bridge mode the EasyVR3 Shield is using. Initialize it. Set up the microphone sensitivity distance from the user and stepper motor for output pins. So there's 4 output pins for the stepper motor. I don't really address any one of them specifically. I just direct all of them. I'll show you here. Here's PC serial begin 96 100. Basically, port. This sets up the bridging stuff. Like I said, this is all part of what you need to get this voice module to work. It comes through here and it detects it. Okay, that's all standard. Just keep it. I set a timeout to infinity, so it will stay and wait indefinitely. Normally you can set this up so that it times out, and you can trap for an error message saying, hey, are you still there, or something like that. I set the language to English. Now I initialize the microphone sensitivity. Here's the distance. I set the microphone to farthest so that I can stand back and talk to it. The strictness level is very low, and the confidence threshold is also low, so that you can almost say anything and it'll still work. But it still catches it. It's still pretty good. I was doing a lot of testing in a room where a TV was on, so I kind of had to set this so that it was a little bit more lenient. Initialize the digital pin as output. So there's 4 pins that lead to the stepper motor, 8 through 11. I initialize them all as output, and they go to the stepper motor. Basically, where is it? It would be right here. You see where it says 1, 2, 3, 4, and this would be 8 would be 1, 2, 9 would be 2, 10 would be 3, 11 would be 4. So you can kind of take these numbers and overlay them with these numbers here, and that's how you read this chart. And I'll show you more about this chart a little bit later on. Here's the word set. Speaker Independent that comes with the EasyVR3 Shield, which I wanted to try to use. It's called a number set. There's one called action set. There's one called motion set or something like that. There's 3 different sets, and you can actually reference there's trigger set. You can set the group equal to number set, and I do down below. And here it's just an array of labels, so I can see it on the screen. So depending on the independent command I give, if I say 0, the index, which is right up here, and I should, the index right here would be 0 if I say the word 0, and so this is, I would do WS3 index, which would give me 0. If I say 1, it'd be WS3 1, which would be an index of 1, and that would come back with that word. So that's how you kind of link it. The loop is 3 sections, so let's just talk about the loop. That's all the setup there is. The loop function is split into 3 sections. Section 1 processes the trigger command motor. Section 2 processes the direction rotation of the stepper motor. The choices are 0 for clockwise and 1 for counterclockwise, which are part of the group of speaker-dependent SD commands. The third section, the last one, are part of the number set work set. There are 11 entries ranging from 0 to 10. Each section prints the receive command name to the serial monitor. Lastly, after all 3 sections have been completed, the stepper motor rotates the number of revolutions returned from the number set. One rotation is equal to 512 sets of 8 steps. Each one of the 8 steps is either high or low based on the 28 BYJ-48 ULN 2003 datasheet. The datasheet has a large table of 4 rows, 1 per wire, and 8 columns, 1 per step, with a dash in the block that indicates a high voltage and a blank block that indicates a low voltage. Clockwise runs steps 1 through 8, while counterclockwise runs steps 8 down to 1. Once completed, the process starts all over, asking for a trigger command, and starts again. And so let me just show you that right here. This is what I'm talking about, is this chart right here. This is really what makes it run. And so, that being said, here I play a sound to show that we're in the loop. We've started. The first group is a trigger set. This is a debug. You can remove it, but I say get trigger, and then I write the LED pin high so I know I can speak, because that I found that helps. You should have some sort of LED or something to let you know whether you can speak or not speak. That way it catches the words only when you want them to. So here we have a do while here. So within this do while, we're going to recognize a custom command. It pulls the status and recognizing for training and playback tasks. Once it finds a command, and this first one's going to be motor, it's going to set the index to the index of motor, and it's going to print it. That's debug, and it's going to play a sound saying it got it, and then it's going to dump the command, because what I need to get is the name. This is the only way I can figure out how to get the name from the trigger set or other sets. Then I print out the name so I know I've got the motor, and once we have a valid non-1 index, because it'll sit here and wait, and sometimes it'll poll right here. If you don't say anything for a while, you'll get a -1, and you want it to keep polling until it's not a -1. And then I write the LED pin low, saying that it's processing, and then I come in to get the rotation, and I set the index to some new number, something way outside the realm. Group 1 is the set to speaker dependent SD commands, which in this case is going to be clockwise or counterclockwise. This is a debug. I just say get the direction, because I would like to know that. I set the green pin high so it's waiting for me to talk. And again, just like above, I sit here and I kind of wait until to find a command that is valid, and it's going to do this do while until it's not a -1. And once it gets an index, it will set the revolution direction to that index. Again, 0 is clockwise, 1 is counterclockwise. I need to get the word clockwise or counterclockwise, so I do a dump. I print just the name, and then I blow through this while statement, and I play a sound saying I'm done. I turn the green light off, saying indicating don't talk anymore. So the third and final step here is get the number of revolutions. Oops. Get the number of revolutions. Here's a debug statement. Get ready to start talking. This can actually be removed. It's debug. I have it commented out. You can delete it. I say the set is equal to EasyVR number set. which is the speaker independent word set that I wanted to kind of use in this sketch. And so here we say a word for the word set, we print the set number, then we get index, and I go down here to get index, and it says read the current group command and return the index value. Get index. Digitally write the pin high. This is a debug. Again, another do while. It recognizes the word. Once it gets a word for the number of revolutions, like 0 through 10, I set that value, get word, to the index number. I print it out here so I can see the number. It will be a number greater than -1, so we'll blow through that, and we play a sound. We turn the green LED off so we know we don't speak anymore, and we go back up here to where is it? Right here, get index. We write the pin low. I think I did that down below, so I probably don't need to do that twice. Anyway, so we say the get index has returned the value, and here's the index number. It's going to be a number from 0 to 10. I print the word from up above using this choose set one words from above code, which is going to be whatever these are, word set. Then once I get that, print that word out, I print each of the revolutions as they occur, because I kind of like to see it revolution 1, 2, 3. Number of revs equals IDX, and I do x equals 1 to x less than or equal to number of revs, and then I bump up x. I say revolution 1, and then here it's one revolution is 512 sets of 8 steps. And this is where I'm going to explain the steps to you. The wiki page that I showed you earlier will describe how to calculate this 512. I'm not going to go into it now, but that does a very nice job of it. But one revolution is 512 steps using my code. One guy, I believe this gentleman here, uses 4,095 micro steps to do one revolution. And his code was hard to use. I spent about a day fiddling with it and had to find something else. It was too difficult to use for what I needed. I found this page actually was better and more informative. And there's easier code out there. So if rev direction is 0, it's clockwise, so we rotate clockwise. Else, if it's 1, then we do counterclockwise. We delay, give it a moment to do its thing, and then we do this for each and every revolution, number of revolutions that we want to do. You know, from 0, which will do nothing, to 10. And so let's just look at clockwise. Clockwise and counterclockwise are exactly the same thing, except the order in which they're called. So here are all the steps, and let's bring up that step thing again. That's that chart. Here's the chart right here, and you'll see step 1. You call for clockwise. You call step 1, 2, 3, 4, 5, all the way through 8, and then for counterclockwise, you start at 8 and go down to 1. And what you do is, we'll bring it up one more time, is step 1 is nothing but high, low, low, low. So I guess it goes this direction. This way. I wrote this. Let's see, did I do it that way? Yes, I did. Okay, so I kind of did it in reverse as far as the numbers, but it still works the same as long as you're consistent. So let's see here. Let me shrink this down just a little bit. No, shoot. So I'm not sure I can get both of these up. So step 2 is this right here, high, high, low, low. And let's see. Step 3 is low, high, low, low. Low, high, low, low. Step 5 is low, high, high, low. Step 4 is low, high, high. And so you get kind of the idea how this plays through. And so on and so forth for each of the phases. And that's for clockwise. I mean, that's for each of the steps. So basically the steps here just call out the direction, the activation of the motor. The counterclockwise or clockwise calls out in which order the steps should be fired or initiated. And that's basically all it does, all the way through down to step 8. And other than that, that's really all you need to know as far as making it run. And there's only 2 states, clockwise and counterclockwise, which is here and here. You give a little delay to kind of let it sync, and then you're done with the loop, and it starts all over. You go right back up to the loop up here. You play a sound, and you start the motor trigger, and the whole process starts over. And it very simple little program. There isn't really a whole lot to it. So I hope that this is helped. I will upload the code to the code bender, and I will try to have a fritzing sketch of this so that you can see how the wiring is. There's an overhead shot showing it working. Please subscribe, leave a comment, share the video with others. Please don't email me because the YouTube email communication doesn't work for me, and I don't want to leave my email address in the YouTube code or in the YouTube site. So unfortunately, I can't really answer any questions. If you want to leave a comment and ask others to update with information, I'm fine with that. I may answer a few things. I got a ton of videos out there, so I'm not really answering a whole lot of videos at all, commenting wise. I kind of just leave it up to those folks that want to use the code and kind of play with it. Go have at it, because it's pretty straightforward. I hope this helps, and talk to you later.